Hi! In this video, I'm going to go over the steps I took to turn an unused Alice Niddle model from Alice Madness Returns into a fully working VRM avatar using Blender. And as someone who started this project as a complete Blender beginner, this process involved a lot more trial and error than I originally anticipated. So instead of presenting this as a perfect tutorial, I'm going to walk through the actual steps I took, including the mistakes and fixes along the way. So I hope you enjoy. The first step was actually finding a usable model online. From the beginning, I already knew what character I wanted to use for the purposes of my university project, and while searching the internet, I came across several different versions of the model in different formats. Eventually, I decided to use an XPS model shared by CryptXPS on DeviantArt, mainly because it already came with a pre-made rig, basically the skeleton that allows the character to move. At first, I thought this would save me a lot of time. Well, spoiler alert, it did not. The problem was that XPS models don't normally work inside of Blender, which is something I didn't know at the time. They're designed for programs like XNA Lara and XPS Viewer, which meant that I needed a special plugin just to import the model into Blender. Once I have installed the XPS plugin that I found online, I was able to bring the model into Blender, but that came with its own set of problems. When XPS models are imported, they usually come with a custom shader setup designed for XPS Viewer. Unfortunately, those shaders don't always behave properly inside of Blender. In my case, several textures simply didn't render the way they're supposed to, and after some research it became pretty clear that the best solution was to rebuild materials manually, which was honestly quite intimidating at first. To fix this problem, I opened the shade editor inside of Blender and replaced existing shaders with Blender's standard principled BSDF shader. Then I reconnected the textures, things like base, color, transparency maps, and normal maps, to the correct inputs. This part involved a lot of trial and error, mostly because XPS materials are often wired in, let's just say, unusual ways. But eventually the model started looking correct again, which was a huge relief after spending arguably hours and hours trying to figure out what goes where. With the materials fixed, I moved on to the big elephant in the room, which was the rig itself. XPS models come with their own bone structures designed specifically for posing in XPS programs. Unfortunately, those rigs aren't compatible with the humanoid rig system required for VRM avatars. So even though the model technically had bones, they wouldn't work for exporting a VRM later. Because of that, I had to make a slightly painful decision. I deleted the entire original rig and decided to start from scratch. Initially, before rebuilding the rig itself, I tried using a program called Maximo to automatically generate a humanoid rig. But because of the model's complexity, the results were honestly kind of terrifying. At that point, I realized I need to stop beating around the bush and just make a custom rig myself. Before rebuilding the rig, however, I also had to decide how I was actually going to convert the model into a VRM avatar. Normally, many VTuber workflows involve exporting the model into Unity and then converting it to VRM there using additional tools. I actually tried that approach briefly. However, while researching the process, I discovered that there's also a VRM plugin for Blender that allows you to prepare and export VRM models directly from Blender. A lot of people online said that the Blender plugin is more complicated than the Unity workflow, but after experimenting with it, I actually found it really useful. Mostly because it allowed me to do everything in one place instead of constantly switching between Blender and Unity. And because I already decided to learn Blender from scratch, basically, the idea of learning Unity as well from scratch was quite intimidating. So I began by creating a new armature in Blender and placing bones for the spine, arms, legs, neck, the head, following a standard humanoid layout. However, VRM models have one important requirement. The character needs to be in a T-pose when the humanoid bones are mapped. The problem was that the original model that I was using came in an A pose. At first, I've decided to ignore this very important detail, which, as you might expect, came back to haunt me later. Eventually, I had to go back, pose the character into a proper T-pose, and set the pose as the rest pose of the rig. Then I had to remake the entire rig itself again. This part was slightly painful, but once it was done, the armature actually looked correct for the first time. After the armature was complete, I attached a mesh to it using automatic weights. Essentially, this tells Blender to automatically calculate how each bone should influence the mesh. It actually works surprisingly well most of the time, but it's rarely perfect. And that's when the next set of problems appeared. The model I was using has long hair, a dress, and a bow at the back, which meant automatic weights caused some very strange behavior. For example, when I moved the arms or legs, parts of the dress would stretch in ways that looked arguably horrifying. To fix this, I switched to weight paint mode. Weight paint sounds complicated, but it's actually pretty intuitive. You're basically painting bone influence directly onto the model. The red areas show where the bone has most control, so if something turns bright red, it means that the bone is strongly affecting that part of the mesh. Using this, I manually removed bone influence from areas that shouldn't be affected, like the dress being controlled by finger bones or the leg controlling hair, etc. I also cleaned up the vertex groups, removing bone assignments that just simply shouldn't exist. Another weird issue I ran into involved incorrect object parenting. Some meshes, like hair and accessories, were accidentally parented to individual bones instead of the armature itself. When that happens, parts of the model can move completely independently, which looks about as cursed as it sounds. So I checked the parenting setup and made sure everything was properly attached to the armature. After testing the rig again in pose mode, the model finally started deforming in the ways that it was supposed to. Alright, so with the model actually moving for the first time, using the edit mode and proportional editing, I created shape keys for things like blinking and opening the mouth. These were later connected to the VRM expression system inside the plugin. So essentially, I had to make mouth movements for every single vowel a VRM model uses, so the character's mouth could move in a somewhat natural way. Fortunately, I didn't need to make any shape keys for the eyes themselves, as they were controlled by individual bones, so they didn't require anything special in that department. With shape keys and the armature all set and done, I was ready to test the model inside of VRM previewers. However, as I did so, I ran into, well, let's just say the classic enemy of 3D models, which is the transparency issues. Parts of the model, like the hair, eyelashes, and necklace on Alice's model, uses transparent textures. When I first exported the model, some parts started disappearing or rendering incorrectly, which is obviously not ideal when half of your character randomly vanishes. To fix this, I adjusted the material settings and changed the blend mode to either opaque or alpha hashed, depending on the mesh. That fixed most of the rendering problems. The hair had one more issue though. When rotating the model, the inside of the hair became invisible. This happens because many video game models use single-sided hair cards, meaning only one side of the mesh is rendered. So if you look at it from the wrong direction, the hair basically disappears. To fix this, I duplicated the hair layer and flipped the normals, allowing both sides of the hair to render correctly. So, once everything was set up, I exported the model as a VRM 1.0 file using the Blender's plugin, and to test the avatar, I ended up importing it into Vardo, which is a software I chose for this project, mainly because it supports hand tracking, which is something I really wanted to experiment with. After connecting my webcam, setting up motion capture, I was finally able to track my movements off of my webcam. Vardo itself also allows me to do some funky animations and play around with my character beyond just tracking my mouth movements, which is something I'm quite excited to learn more about. And with that being said, thank you so much for watching my process of creating this model, and I hope you enjoyed.